These are my team members: Akanksha Nayak, Nitin Aryan, Amisha Raut, Ajit Kumar Kar, Parvati Sharma, and Sneha Pandey. Moving on, the deep drawing process involves 5 stages: bending, straightening, friction, compression, and tension. First is bending. As the application of load starts, the blank is first bent onto the round edge of the die cavity. Straightening. Now, with the further increase of the load, the bent part of the blank is straightened in order to sink the angular punch die clearance. The result is short, straight, vertical wall formation. Third, friction. Next, the rest of the blank starts to flow radially and to sink into the die pool. But the frictional force between the lower surface of the blank and upper flat surface of die try to impede that flow. The magnitude of frictional force drops as the blank metal starts to move. Compression. Now, the blank undergoes compressive stresses. The width of the sector shrinks so that the larger perimeter of the blank can fit into the smaller perimeter of the die cavity. Last, tension. With further increase in the applied load, almost all the metal blank sinks into the die cavity, thus forming a long vertical wall. The remaining blank part takes the form of a small annular flange. The vertical wall is subjected to uniaxial tension. Now, Akanksha will explain further.
Next slide. Hello everyone. Now let's discuss about some of the variables affecting deep drawing. Blank holder. The blank is held against the rubber pad by a blank holder through which a punch is acting in a conventional deep drawing. It is a double-acting apparatus. At first, the ram slides stand, then the blank holder moves. Then comes the die corner radius. The die corner radius plays a vital role in manufacturing the product in deep drawing process. Lower the die corner radius, the part is subjected to tearing effect, and higher the die corner radius, wrinkling is observed. This comes geometry of the bend. Bending is an acceptable size with respect to the drawing punch size, so the metal will flow inward and less stressing will occur. The part geometry is 2 or more times as tall as the minimum part width. Then comes the drawing ratio. The higher the drawing ratio, the more extreme the amount of deep drawing. Due to the geometry, process, metal flow and material properties of the wall, there is a limit to the amount of deep drawing that can be performed on a sheet metal blank in a single operation. Then, percentage reduction. The value for percentage reduction usually takes as 30% for the first draw, 20% for the second, and 10% for the third draw. The product should be annealed after every 2 redrawing operation in order to eliminate the work hardening and thus avoid any cracking of the product. So these are the main factors of deep drawing which needs to be considered. That's all from my side. Thank you. Over to next.
Let us now see about theoretical consideration taken in deep drawing process. First one is determination of radial and hoop stress. As the punch starts to press the blank downward through the die opening, the outer radius of the blank decreases continuously throughout the drawing process. And at an instant, assuming frictionless drawing condition, for simplicity, this radial stress of 8 Rx at any radius x is determined from the following equation. 6 Rx divided by 1.1 y is equal to log of b by x, and the tangential stress 60 Rx is determined from 60 Rx divided by 1.1 y equal to ln 1 minus ln of b of x, b by x. Second one is determination of maximum height after first draw. Considering a circular blank of diameter 2a and a original thickness is to be formed into cylindrical cup of base diameter 2b and a height of h, where a and b are the radii of cylindrical cup. For simplicity, assuming there is no change in thickness, which is very justified from the experimental results of the work in this process, and the work of the other researchers applying the constant volume principle in plastic deformation is get a to the power 2 x 2 is equal to b to the power 2x 2 plus 2bx whole of h of x, and simplifying this to get where r is the drawing ratio, h is equal to 2a by 2b, and height h is equal to b by 2 of whole of r square minus 1, and the r is taken to be 2.2, which is the limiting drawing ratio in LDR. By subtracting the value in the equation 4, then the maximum obtaining value of h is equal to 2b. That is not possible to obtain a cup whose height is bigger than the base diameter. This is very useful engineer and technician in industries, because by looking at the drawing of required part can be decided if you can produce it from the first stage or we need a redrawing process. So in this section, the major parameter affecting the deep drawing process will be discussed by my other fellow mates. Over to
Next slide. Hello everyone. Here I will discuss about what are the parameters affecting the mechanism of deep drawing. The first one is ironing. It is the operation of thinning the side walls and increasing the height. It reduces the wall thickness of the cup by restricting the clearance between the punch and die to a value less than the blank thickness. The punch load is of the primary importance in ironing because it determines the tension in the cup walls and hence the maximum reduction possible for a given punch load. Then gelling. It is the transfer of some particles from the cup wall into the part of the die in contact with it. It causes damage to the die wall. It depends on the hardness of the plank. It can be avoided by keeping the die surface in very good quality and using efficient lubricants to reduce the friction between the cup and the die surface in contact with it. Then orange peeling. It occurs at the outer surface of the cup when the grain size of its material is large. It can be avoided by reducing the grain size prior to drawing, either by heat treatment or by adding grain refinings. Then earring. Earring occurs when the material is anisotropic, that is, varying properties in different directions. It is the formation of waviness on uppermost portion of the deep drawn cup and is treated by trimming. Then tearing. It might take place at the inner region of the rim. Down press which is the blanks heading and bending over the die profile, radius or text in the thinning region near the punch profile, which is subjected to bending and stretching. Then wrinkling. This defect starts in the rim region of the plank and travels towards the middle region. The movement of the plank into the die cavity induces compressive stress in the flange, causing a series of ridges radially on undrawn part of flange. This can be reduced by keeping a blank holder under the effect of the holding force. Our side